Welcome to our free diesel tuning series. I'm Nick Priegnitz with HP Academy. In this instructional series, you're going to learn the fundamentals of diesel tuning and how we can extract more power out of late model diesel engines. I've owned calibrated power and Duramax tuners since 2007, which means I've been performance tuning diesels for about 13 years. I've seen just about anything that can happen in the performance arena of diesel tuning. I've also got to see the industry grow, see new parts come, and see new techniques and new theories on tuning. It's been an interesting road, and there's a lot of experience that I can share with you through this series. Let's start with how a diesel engine works. So typically, if you're coming from a gas world, you're used to a spark plug igniting things. Well, in a diesel engine, there is no spark plug. In a diesel, we're looking at compression. As that piston comes up and drives heat into the combustion chamber, there's enough heat there to light that charge off. So as the fuel is injected by the injector into that cylinder, directly into that cylinder, that's going to start the combustion process. Things that we don't have in a diesel engine that we have in a gasoline engine: a throttle and spark plugs. That makes the diesel engine tuning process quite a bit different from the spark ignition process. The things I love about tuning diesel engines is that you don't have to worry about pre-ignition, you don't have to worry about knock. You do have to worry about cylinder pressure. So octane is not an issue, right? We can run as much boost as our parts can handle. We're never going to have pre-ignition, we're never going to have detonation. That means we can make a lot of torque. That means we can run stage turbocharging, we can run a ton of boost, whereas in a gasoline application, you're really only as good on the torque side as the fuel that you have. So you can only make so much power with gasoline, then you have to step up to alcohol or racing fuel or methanol or whatever it is. But on the diesel side, we can make a lot of torque. The beautiful thing about these late model engines is that they come equipped with overhead. That means that there's room in the design over and above what they're rated for from the factory. For instance, this 2020 L5P makes about 405 to 407 horsepower traditionally at the rear wheels on our dyno. By tuning the truck, we're able to easily add 80, 90, 100 horsepower and run the truck reliably and durably long term. We're able to get almost double that if we push the truck into a competition scenario. Why is that? A lot of it has to do with turbocharging and electronics. So we have the ability to add more air to the system via the turbocharger, and we have the ability to add more fuel to the system. And that's really how the secret to making power with the diesel engine is getting control over the fuel system. Now, these late model engines are totally controlled by the engine control module. That means that rail pressure, so the pressure that the fuel is injected into the cylinder, the timing of that fuel, pilot injection quantity, the turbocharger, all those elements that control the amount of fuel and the amount of air that goes into the cylinder, and thus the amount of torque the engine can make, are electronically controlled. Now, the factory's not just going to toss you the keys to that and say, have at it, do your worst. We have to go at it with some tact, and we have to know what we're doing so that we don't hurt the engine. And that's where understanding the fundamentals and getting a good handle on how this process works using the HPA system is going to really come in handy. So let's dive into this a little bit. Let's talk about the power production process in a diesel. I've pulled up a tune file from this 2020 L5P to walk you through a little bit of the basics, just to show you what happens. So if you come from the gas tuning world, you know what a throttle blade is, you've seen a carburetor, you know what it means to snap the throttle and allow more airflow into the engine. Well, on a diesel, there's no throttle, and the engine can eat as much air as it wants. So really what we're controlling is the fuel rate. And as we fuel the engine harder, we're going to make more exhaust mass, more turbine energy, and we're going to be able to drive that turbocharger to get more air into the engine. So the response on a diesel engine isn't necessarily as crisp as a gas engine all the time. Sometimes you have to wait for the turbocharger to come to life. However, the ability to make torque is there. So on this L5P, let's jump into it. Let's talk about the basics. So driver demand. This is how HP Tuners has the software laid out. Different tuning softwares have different layouts, but we'll use HP Tuners today. I just want to draw your attention to how the power production process is laid out in HP Tuners. So across the top axis here we have ground speed, from 2 miles an hour to 200 miles an hour. And across the side axis, we have the throttle position. So as you push the throttle harder, you're going to command more power. You can see that at 0 throttle position, we're commanding negative power. Now you're really not going to make negative power with the engine. As you tip into that 2-4%, you start to make power. And as you push the throttle harder, you're going to go from smaller numbers to bigger numbers. And those bigger numbers are going to drive more torque production. So as you're commanding more power, more horsepower out of the engine, we're going to develop torque. Now, how does the engine know to make torque? Well, let's jump over to the torque-based fueling map. I just want to show you these maps here, just to give you an idea of how the engine looks up how to make power. So as it knows power and it knows RPM, it can derive torque. Torque is a function of power and RPM. This engine, let's say it wants to look up to make 664 foot-pounds of torque at 2,000 RPM. Well, this table tells that engine that it needs 77 MM3, or milligrams of fuel. Now, those milligrams of fuel are going to be injected on every Powerstroke, on every cylinder. So it's a very small amount of fuel, but that fuel rate, as we'll call it, that 77 milligrams, is going to drive the rest of what this engine's doing. So now that it knows that it needs 77 milligrams, it's going to go out and it's going to look up how much air it needs. It's going to go out and it's going to look up how much rail pressure it needs, how much timing it needs, the EGR position, and a whole host of other engine variables, and it's going to put that whole picture together. So if you know RPM and you know the fuel rate, you can really put the rest of the picture together. Now, our goal as tuners, of course, is to maintain stoichiometric or limits. Unlike a gasoline engine where we don't want to run the engine lean, on a diesel engine, there's rich limits. There's some benefit both to the emission system and to the long-term health of the engine to keep the engine at a lambda somewhere in the 1.15 to 1.2 range. If you go any richer than that, you really start to add a lot of exhaust gas temperature, and you start to kind of hinder the long-term durability of the engine. And you're going to see me hit on this point as we go through these lessons. Now, our goal as tuners is to maintain those limits and to maintain that the engine knows how to measure those things. So let's dive in a little bit and look at some of those other parameters that are driven off of fuel rate. Let's look at timing, for instance. Diesel injection timing. So this table style is similar to how a lot of the tables in the engine control module are laid out. It's RPM versus fuel rate. Okay, we talked about the fuel rate before. We said 77 on that 664 foot-pounds at whatever RPM that was. So this table is going to tell us that, you know, at that fuel rate, between 70 and 80, and at whatever RPM we're operating, this is going to be the start of injection for timing, for the main injection timing event. So, interesting, on a gasoline engine, in this upper left-hand corner, this light load corner, you'd expect to see high timing numbers, right? 35 up to 48 maybe. On a diesel engine, we're really concerned with noise, vibration, harshness, and we're only injecting a very small amount of fuel, so we don't need to lead it. We can put it in just about right at top dead center or just after top dead center, and that's going to result in lower NOx emissions, lower noise, lower vibration, lower harshness. That's part of why these modern diesel engines are so quiet and nice to drive. Now we get into the high load scenario in the bottom right hand corner, and you can see that this is a factory table. You can see the factory's ramped in quite a bit more timing. When we need to keep the injector on longer, so that is pulse width, to drive more fuel. So as we command more fuel, higher fuel rates, we're going to need higher injection pressure and larger pulse widths. That is keeping the injector on longer and running it at higher pressure. When you keep the injector on longer, you need to lead it a little bit more. To do that, you need more injection timing. Now there's a delay between injection timing and the start of combustion, and these things all get played into the tune. Boost and cylinder pressure and cylinder heat have a lot to do with that. Just so you kind of understand the shape of the stock timing curve, it's interesting to see. Let's jump over to boost. We talked about fuel rate. Again, this map is very similar to the timing layout. So as we're looking up timing, we can also look up boost. Between 70 and 80, depending on the RPM that the engine's operating at, here's going to be your boost number. All right. And you can see this is total, so subtract 14.5 off of that to get your gauge reading. Of course, these are adjustable, but we would only adjust these if we were in a situation where our lambda was out of control. So we were running the truck too rich at 70 or 80 MM3 and we need to get more air in, then we would go in and we would command more boost. An interesting thing on these trucks is the modern turbochargers. They're on PID control, so we can command boost, and those vanes are going to move, and they're going to move within their limits in order to get more turbine energy out of that turbocharger, spin the turbocharger faster, and get us that power that we want, get us that extra airflow, so we can get that good stoichiometric, good efficient burn out of the truck. And let's take a look at injection pressure. This table, again, set up very similar to the boost pressure table, very similar to the timing table, is looking up based on fuel rate and RPM. So as we target a certain fuel rate, let's say that between 70 and 80, 77, at maybe 2,000 RPM, we're going to be commanding 190 to 191 MPa. So that's megapascals. And that's somewhere in the 28,000, 27,000 PSI for the fuel pressure. It's a lot of fuel pressure. You know, there's only three elements that go into the fuel quantity. You have the nozzle size, the fuel pressure, and the duration. So we can't change nozzle size dynamically in the tune. That's kind of preset by the factory. But we can change pressure and we can change duration. So why would we want to change pressure? Pressure is a lot like timing. If you add a lot of fuel pressure to the truck down low, when it doesn't have boost, and you get a lot of noise and vibration and harshness. So when you're injecting small quantities, you don't need a lot of fuel pressure. Keep in mind these pumps also take horsepower to run, so these high pressure pumps take power. So if you want to run 30,000 pounds of rail pressure, I mean, you can imagine what a pressure washer feels like when you pull on the cord when it's got pressure, right? So the less pressure we can run and still make that power efficiently, the quieter the truck is going to be, the less NOx emissions we're going to have, and generally the nicer it's going to be to drive. Now, these high pressure systems being able to run between 3,000 psi and 30,000 psi give us a lot of dynamic range on the injector and a lot we can do as far as events. So multiple injection events to really space out and shape the rise and fall of the combustion pressure peak. That's going to allow us to control NOx emissions, allow us to get good power and still meet our emission standards. By now you're probably wondering, how much power can I make with just tuning on one of these trucks? I mean, what's really on the table? Well, of course it depends truck to truck, right? But on this 2020 L5P, for instance, we just took it from 407 horsepower at the tires, and then that last dyno pass was right at 498, 499. And that's not even leaning on the truck very hard. That's maintaining a nice stoichiometric limit, so we're not going crazy on our lambda. We're still in the 17.5 to 1, and we're not pushing the truck crazy hard. That's 90 horsepower, and almost double that for torque. That's a nice gain. You're going to really feel that in the seat of the pants. You're going to really feel that in gear, so not having to downshift while towing, not having to downshift while passing, being able to lean on the throttle and use the power of the truck, use the torque of the truck. It just makes an overall nicer driving experience. Imagine how much fun you'll have using the HPA classes to get that response out of your truck. Follow me into our next lesson in Module 2. We'll look at software and hardware requirements for tuning, and talk about some of the sensors and other stuff that's needed to get started tuning and go down that road on your own.